Hey guys, welcome to Advanced Math. Today we are going to take a look at quadrilaterals in 5.3. This is a part of our geometry review unit. Again, none of this information should be new. It's always good to go back and review what we've done in previous years. So let's go ahead and get started. Our biblical correlation comes from Colossians 1:16 through 17, which says, "For by him all things were created, things in heaven and on earth, visible and invisible, whether thrones or powers or rulers or authorities, all things were created by him and for him. He is before all things, and in him all things hold together." Now, when we talk about things being created, we know that we've got it says things in heaven and on earth, visible and invisible. And we talk about the visible things all the time. He created the animals and the plants and people. The invisible things, at the time that this was written, some of the invisible things would have been chemicals, molecules, atoms. Those things were invisible. Paul couldn't have written God created atoms and molecules, because the Jews at that time and the Greeks at the time and the Romans would have been like, what in the world is a molecule or an atom? But those are some of the things that were invisible at the time that we now know exist. It's still not visible to the naked eye, but some other invisible things are those patterns that we see, like the Pythagorean theorem, or the fact that interior angles add up to 180. They're not marked with visible numbers, but we've discovered those patterns, and God has created all of these things and given us this order and this structure to use so that we can take care of the world around us. So we looked at triangles last class. Let's take a look today at quadrilaterals. Your objective for today, you will use the proper names of quadrilaterals plus the properties of quadrilaterals to determine angle measure, area, and perimeter. Now, we looked at the proper names of quadrilaterals already in a previous lesson, so we're just going to review those today and then talk about how we can figure out missing angle measures, area, and perimeter. You already know that quad means four and lateral means side, so a quadrilateral has four sides. In quadrilaterals, the sides do have to be straight in order to be a polygon. That is part of that definition, and they do need to be two-dimensional. We're only talking about 2D shapes, not 3D shapes just yet. Here are some examples of quadrilaterals. As you can see, they have four sides, and they are all straight and two-dimensional. Quadrilaterals, have four sides or edges. They also have four vertices or corners. A vertices or vertex is where two edges or two sides meet. And we know, based on our sum of interior angles formula, that the interior angles have to add up to 360 degrees. Number of sides is 4 minus 2, and then 2 times 180 is 360 degrees. So let's take a look at some proper names of quadrilaterals here. All right, this is a parallelogram. A parallelogram has two sets of parallel sides. Now, you saw previously when we talked about triangles that we use these hash marks to indicate that sides are congruent. They are the same length. So this one and this one are the same, and this one and this one are the same. There's another type of mark that we can use to indicate that the sides are parallel, and that's going to be what looks like the tip of an arrow. So this one and this one are parallel, and we'll do a double one here to indicate a second set of parallel lines. This one and this one are parallel. So any shape that has two sets of parallel sides is a type of parallelogram. Underneath that type of parallelogram, we have even more specific types. So you can see that this shape also has two parallel sides. So this is a parallelogram as well. But we can be more specific because it's a specific type of parallelogram and call it a rectangle. Not only does it have two sets of parallel sides, but it also has four right angles. So a rectangle is a type of parallelogram that has four right angles. All right, let's take a look at this shape here. This is a rhombus. And what a rhombus has is four congruent sides, four sides that are the same. Again, it is a type of parallelogram because we do have this one and this one that are parallel, and this one and this one that are parallel. But what makes it a little bit more unique is that all sides are the same. Like a square. A square also has four congruent sides. So here we have another type. It's a type of rhombus. It's a type of parallelogram. It's also a type of rectangle, but the most specific name that we can give it is a square. And let's talk about why it meets all these things. First of all, it's a parallelogram because it has two sets of parallel sides. It's a rectangle because it has four 90-degree angles. And it's also a type of rhombus because all the sides are the same length. So you can see a square is just like you put all those together. It's a parallelogram, rectangle, rhombus. It's all three of those. It meets the classifications of all three. The most specific name we can give it is a square. Another type of quadrilateral here is a trapezoid or a trapezium. Although trapezoid is the name that you're going to hear the most. And a trapezoid also has parallel sides, but a parallelogram had two sets of parallel sides. And a trapezoid only has one set or one pair of parallel sides. You can see that this side on the left and this side on the right are not parallel. So trapezoid has one set or one pair of parallel sides. All right. This shape is called a kite. And a kite has two congruent sides, so these two would be the same, and two other congruent sides. Boom, 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 boom. So that is what our definition of a kite is. Two sets or two congruent sides. All right, you've seen this kind of similar to this already previously in our unit, but this is our family tree of quadrilaterals here. So in the quadrilateral family, we have first the trapezoid, that's one set of parallel sides. And sometimes you'll see this separated, not as a type of trapezoid. The one that we have already has this as just a separate qualification or classification. So we have a trapezoid, one set of parallel sides, an isosceles trapezoid, which has these two sides parallel and the two opposite sides congruent. Parallelogram, we've said, has two sets of parallel sides, so 1 and 2. And a parallelogram can be further broken down into a rectangle, which has four 90-degree angles, or a rhombus, which has all sides the same, but not 90-degree angles, and a square, which has both 90-degree angles of a rectangle and all sides the same like a rhombus. Our last quadrilateral over here is the kite, which has two congruent sides, and then the other two sides are also congruent to each other too. So two sets of congruent sides. A little bit different from the one that you have already in your notes, but very, very similar. Some other names for our shapes or quadrilaterals here, other polygons. We've got quadrangles, which means four angles. Think about like a triangle, which has three angles, although you won't hear the word quadrangle very often. We could also call it a tetragon. Tetra means four, so it's a four-sided polygon, tetragon. So pentagon is a five-sided polygon, hexagon, a six-sided polygon. You will not hear a quadrangle or a tetragon very often. Other names of shapes that we've already looked at, we had the triangle that we looked at last time, quadrilateral that we're looking at today, and then we have all these other shapes that we looked at previously, like pentagon, hexagon, octagon, nonagon, decagon, so forth and so on, classifying shapes by their sides. All of these are types of polygons. Poly meaning many, so many-sided figure. Polygons do have straight edges, therefore circles don't fit under that polygon classification. All right, let's talk about now perimeter and area. We talked about perimeter very briefly last time with triangles, and how perimeter is just the distance around a two-dimensional shape. To find perimeter, we add up all the sides. So to find the perimeter of this rectangle, we would add up all the sides. 7 plus 3 plus 7 plus 3, or we can do two groups of 7 and two groups of 3. So we could write it this way, two groups of 7 plus two groups of 3, whichever way is easiest for you. And when we do that, we do get our perimeter is 20, and then we're going to write the word units. If you're not told the unit of measure, whether it's inches, feet, meters, miles, whatever it may be, we just need to write the word units. So it is 20 units. To find the perimeter of a pentagon or any shape, again, we add up all the sides. A pentagon has 5 sides, and each of these sides, because it's a regular pentagon, is the same. So we have 3 plus 3 plus 3 plus 3, or 5 groups of 3. You can write it that way, which means that our perimeter is 15. Again, we're going to write the word units. 15 units. If you're not told the unit, just write the word units. Remember, again, I just mentioned it, but regular does mean that all the sides are the same. So even if you had not been given these numbers, if you had only been given one side, but you were told it was a regular pentagon, you could have concluded that all of the sides were the same. All of the sides would have been 3. All right. We can also use area and perimeter when we're trying to find the area and perimeter formulas when we're trying to find these complex shapes. If you take a look at this shape, it's overall kind of an L shape here. And in order to find the perimeter of that shape, we've got to add up all of the sides. And sometimes it helps to kind of break it apart into shapes that you're more familiar with, like a square. As you can see, this has been broken up into squares and rectangles. So we're told that this side is 3. This side is 3, this side is 4, this side is 4, and we can use that information then to determine, well, if this side is 4 and this side is 4, this side must be 4, and if this is 3 and this is 3, this side must be 3, so we're dealing with squares here. And then this must be a rectangle. If this side is 4 and this side is 3, then this side is 4 and this side is 3. So we have to fill in kind of all these missing numbers. From there, if this is 4 and this is 3, we know that the total length of this side is 7. And we know that if this is 4 and this is 3, the total length of that side is also 7. All right, after we filled in all of the missing pieces, kind of like a puzzle, we can then add up the outside lengths of 4 plus 4 plus 7. I'll go this way. 4 plus 4 plus 7. Then we got another 4 plus 3, or 7, and 3 plus 3. So you can see that here, 4 plus 4 plus 7, plus 4 plus 3, or 7 if you wrote it that way, plus 3, we get 28 units. All right, to find the area, let's see if I can erase some of the marks that I made up here, kind of clean this up a little bit. To find the area of a shape that's kind of a composite of different shapes, again, we got to find the area of the different pieces. So find the area of the 3 shapes. So this first square right here, to find the area of a square is 4 times 4. So this area is 16. And to find the area of this square, we take 3 times 3, which is 9. And then the area of this rectangle we said was 4 times 3 is 12. Now that we know the area of our 3 separate pieces, we add those together. 9 plus 16 plus 12 is 37 units squared. Okay, because we're trying to find how many square units are inside each one, we're using that units squared label. All right. Let's talk about how to find the perimeter, again, of some odd shapes. We know that to find the perimeter, we add up all the sides, but if you look here, we don't know all the sides. So we got to do a little bit of side math, some background work here to find the different sides that are missing. So we know that this side is 6 and this side is 12. And we know this side is 6. So that must mean from here to here is also 6. I've got to break this apart into shapes that I can work with. And when I look at this, it looks like it's really, oops, this is not going to be a straight line. There we go, a square with 2 triangles. And it looks like this is about maybe halfway to my triangles here. So if the length of this whole thing is 6 and I've broken it apart into 2, that must mean that each of these is 3. And again, 6 and 3. Okay. What I need to find now is the length of these sides. Well, it looks like I've made some right triangles, and I know from previous work that to find the missing side of a right triangle, I can use the Pythagorean theorem. So let's go ahead and use the Pythagorean theorem here. I'm going to take my 3 and my 6 and use those to find that hypotenuse. 6 squared plus 3 squared is 36 plus 9. So I get 45 is equal to c squared. In order to get the c by itself, you know we've got to take the square root here. That means c is equal to the square root of 45. Because we are going to have to do some addition, we're going to go ahead and change that to a decimal. When you plug it into your calculator, the square root of 45 is about, that means about 6.7. We did have to round it there. All right, so now we know our 2 last sides are 6.7, and we can add up all the sides. We've got 12 plus 6 plus another 12 down here plus 6.7 plus 6.7 gives us 43.4. In this case, we are told the unit of measure, m is for meters, so 40